In 1942, Hermann Göring, the head of the Luftwaffe, received a report about his new heavy bomber, the Heinkel He-177. He read the casualty statistics and famously screamed at his engineers, "What kind of engines are these? Are they welded together?" He was furious because the pride of the German bomber fleet was not destroying London or Moscow. It was destroying itself, often bursting into flames before it even reached the enemy coast. This aircraft was known to its crews as the Luftwaffenfeuerzeug, the Luftwaffe's lighter, or more simply, the flaming coffin. This is the engineering audit of Germany's only attempt to build a strategic heavy bomber. It is the story of how a single, insane design requirement, the ability to dive, doomed the entire project. To understand this failure, we must look at the strategic gap in the German arsenal. The Allies had the B-17 Flying Fortress and the Avro Lancaster, massive four-engine planes that flattened German industry. Germany had nothing comparable. They had excellent tactical bombers like the He-111 and Ju-88, but these were medium-range aircraft. They lacked a Ural bomber, a plane capable of flying deep into Russia to destroy the factories behind the Urals. In 1938, the German Air Ministry, RLM, issued a specification for a long-range heavy bomber, but they added a requirement that defied the laws of aerodynamics and common sense. They demanded that this massive 30-ton aircraft be capable of dive bombing. Dive bombing requires a plane to drop vertically at a 60-degree angle, release a bomb, and pull up under immense G-forces. Asking a heavy bomber to dive is like asking a school bus to perform gymnastics. The structural reinforcement needed to survive the pull-out adds massive weight to the airframe. But the real problem was drag. A four-engine plane creates too much drag to dive efficiently. So, the engineers at Heinkel came up with a radical, fatal solution to reduce the aerodynamic profile. They decided to use four engines, but they wouldn't mount them in four separate nacelles on the wings. Instead, they mounted two engines side by side in a single nacelle and connected them to a single propeller. This was the Daimler-Benz DB 606 power system. It consisted of two DB 601 engines, the same engine used in the Bf 109 fighter, coupled together by a massive gearbox. On paper, this looked brilliant. You got the power of four engines with the drag of only two. The plane looked sleek and clean, lacking the bulky engine pods of a B-17. But in reality, they had created a thermodynamic nightmare inside the wing. By packing two massive V-12 engines into one tight cowling, they eliminated the airflow needed for cooling. The exhaust manifolds of the inner cylinder banks were facing each other, glowing red-hot in a confined space. Normally, heat radiates away. In the He-177, the heat had nowhere to go. It cooked the oil lines and the fuel lines running through the engine bay. Leaking oil or fuel would drip onto the glowing red exhaust pipes, causing an instant, uncontrollable fire. This is why it was called the flaming coffin. Pilots reported that the engines would catch fire simply from running at combat power for too long. The gearbox connecting the two engines was another point of failure. The crankshafts of the two engines had to be perfectly synchronized. If one engine hiccuped or ran slightly rough, the torque would shatter the transmission gears. Imagine trying to drive a car where two separate engines are fighting to turn the same driveshaft. The He-177 first flew in November 1939, but the engine fires were so frequent that production was delayed for years. By the time it entered service in 1942, the strategic situation had changed completely. Germany was no longer on the offensive. It was fighting for survival on the Eastern Front. The Luftwaffe needed the He-177 to supply the surrounded 6th Army at Stalingrad. The He-177 was designed as a bomber, not a transport, but desperation forced them to improvise. They stripped out the bomb racks and loaded the planes with bread and ammunition. But the He-177 was useless in the harsh Russian winter. The complex coupled engines required careful maintenance, which was impossible in a frozen field with no hangars. Mechanics hated the plane. To change a spark plug on the inner cylinder bank, you practically had to dismantle the wing. The serviceability rate was abysmal. For every one plane flying, 4 were broken on the ground. At Stalingrad, the He-177s failed to deliver enough supplies to save the Sixth Army. Instead, they littered the steppe with burning wreckage, victims of their own overheating engines. The obsession with dive bombing was finally dropped in 1942, but it was too late to redesign the engines. The airframe was already built around the DB-606 coupled system. Heinkel tried to fix the problem by designing a four-engine version with separate nacelles, the He-277. But Hitler forbade it. He wanted the production lines to focus on what was already being built. This is a classic example of the sunk cost fallacy. The Germans had invested so much time and money in the coupled engine design that they refused to abandon it. They kept building a plane they knew was defective, hoping that a minor tweak would fix a fundamental flaw. It never did. The fires continued until the end of the war. We must also look at the defensive armament of the He-177. It introduced the Fernbedienbar Drehleifett, remote-controlled rotating gun mount. Gunners didn't sit in the turrets. They sat in the cockpit and aimed via periscopes. This was advanced technology, reducing drag and protecting the crew. But like the engines, the complex electrical systems were prone to failure. If the electric drive failed, the gun was useless, leaving the bomber defenseless against Allied fighters. The He-177 also had a massive fuel consumption problem. The twin-coupled engines guzzled high-octane aviation fuel at a rate Germany could not sustain. By 1944, as the oil crisis deepened, see our previous video, the He-177 fleet was effectively grounded. Hundreds of these massive bombers sat on airfields, camouflaged with nets, waiting for fuel that never came. They became sitting ducks for American Mustang pilots roaming over Germany. It is ironic that the only strategic bomber Germany built spent most of the war parked on the grass. There was one operational success story, Operation Steinbock, the baby Blitz, in 1944. The Luftwaffe gathered a fleet of He-177s to bomb London in retaliation for the destruction of German cities. Because of their high speed, thanks to the aerodynamic drag reduction, they were hard to intercept. They climbed high and dived shallowly, not vertically, toward London, releasing their loads. But the mechanical attrition was staggering. In many raids, more He-177s were lost to engine fires and accidents than to British night fighters. The British radar operators were confused by the He-177. On radar, it looked like a heavy bomber, but it moved like a medium bomber. However, the baby Blitz failed to do significant damage because there were too few planes. You cannot win a strategic air war with 50 bombers that might burn up on takeoff. The Allies built 12,000 B-17s. Germany built roughly 1,100 He-177s. And of those 100, a significant percentage were prototypes or destroyed in accidents. The He-177 program consumed a massive amount of aluminum and engineering talent. Ernst Heinkel, the designer, later admitted that the coupled engine was the greatest mistake of his career. He had fought the Air Ministry, begging to use 4 separate engines, but the dive requirement overruled him. This highlights the incompetence of the Nazi leadership in technical matters. Men like Goring and Udet, the head of procurement, were WWII fighter aces. They understood dogfighting. They did not understand strategic logistics or heavy bomber physics. They treated a 30-ton bomber like a Stuka because that's what they knew. This tactical myopia meant Germany never developed a true strategic air arm. They fought a tactical war, support the tanks, while the Allies fought a strategic war, destroy the factories. The He-177 was a weapon without a doctrine. Even if it had worked perfectly, the Germans didn't know how to use it strategically. They used it for maritime patrol, hunting convoys in the Atlantic using guided glide bombs, Fritz X. The He-177 was actually a decent platform for launching guided missiles. It sank several ships, including the Italian battleship Roma, flown by Do-217s, but He-177s carried them too. But using a heavy bomber to hunt single ships is an inefficient use of resources. It's like using a sledgehammer to kill a mosquito. In the final months of the war, the He-177 fleet was scrapped for metal. The aluminum was needed to build fighter jets like the Me-262. The engines were pulled out and likely melted down. The flaming Coffin didn't go out in a blaze of glory. It was recycled into something else. Today, there is not a single complete He-177 left in existence. Only fragments remain in museums, twisted pieces of metal that tell a story of failure. The He-177 serves as a warning against feature creep in engineering. When you try to make one machine do everything, bomb, dive, fly fast, carry missiles, it does nothing well. The B-17 did one thing: fly high and drop bombs. It couldn't dive. It wasn't fast, but it was reliable. It came home with 2 engines shot out. The He-177 couldn't come home with all engines working because they were actively trying to kill the pilot. Reliability is a quality all its own. The German engineers sought perfection and achieved complexity. The Allied engineers sought utility and achieved victory. The Heinkel He-177 was the embodiment of the Third Reich's industrial schizophrenia. Brilliant innovation, remote turrets, coupled engines, married to suicidal stupidity, dive bombing. It burned its pilots, it burned its fuel, and ultimately, it burned the hopes of the Luftwaffe. It remains the most sophisticated failure in the history of military aviation. So, the next time you see a picture of a B-17 flying fortress, remember its German rival, the He-177 Greif. Remember the pilots who looked at those glowing exhaust pipes and prayed the oil line wouldn't burst. They were fighting 2 enemies, the Allies in the air and the Design Bureau in Berlin, and in the end, the Design Bureau was the deadlier of the 2.